Good morning to one and all. Today's topic is related to stabilization and its importance. In the previous class, we discussed different features which affects the strength of the soil and how to mitigate those features of the soil. That means the different properties of the soils we are having. That means those are strength parameters and permeability parameters, how they will affect the soil strength, and after constructing a structure, those parameters how they affect the structure. All those things we have discussed in the previous class, but in today's class we have to know how we need to go for stabilization, what we have to face without stabilization of the soil. That means if the stabilization is not done for a particular quantity of soil and simply we are construct a structure, after the construction what kind of difficulties we have to face, and before going to construction, to arrest those difficulties, what are the techniques we have to implement in the structure itself, that means in the soil profile. First of all, we have to know the importance. In those importance also itself, we have to know what are the different features we have to implement in the site. Soil stabilization is the process of improving engineering properties. That means for the soil we are having majorly three kind of properties. First one is the physical properties. That means physics means the shape, size and its diameter. All those are comes under physical parameters. Second one is the chemical parameters. That means what quantity of substance it is. That means in the particular substance what are the different chemicals lie, how the chemicals will affect the surroundings. All those are comes under chemical properties. Next one is the engineering properties. In those engineering properties, what we have to learn is strength properties. That means shear strength, compressive strength and tensile strength. All those are the engineering properties. For a quantity of soil, exactly what we have to know is the strength properties. If the strength of the soil is high, automatically we have to go for a good quantity of structure with a huge amount of load conditions. If the structure is very weak, automatically we have to restrict the size in the form of length. That means we won't have to go for a lengthy structures. Normally we have to prefer a small scale structures, so that we have to go for stabilizations when we are constructing a length and strength structures. It is required when the soil available for the construction is not suitable for the intended purpose. That means it is required. Here it is means stabilization is required when the soil is available is not suitable. That means here not suitable for the construction, automatically the engineering properties of the soil are very weak compared to a normal soil. That means normally soils having different properties according to their state of formation and erosional properties, but here what we have to observe is especially engineering properties we have to observe. If the engineering properties of the soil are very good, automatically the structure will have to withstand for a long period of time and we won't face any difficulties. Here difficulties means automatically whenever the structure having irregularity of loading and there is no proper stabilization, automatically structure will shows different quantities of cracks. That means a lengthy crack or smaller cracks. Normally cracks we have to observe in different structures, likely those are having differential settlements in the ground itself. Why? Because if there is no stabilization, automatically due to the gravity the structure will sink down, so that we need to go for stabilization before constructing a structure, and the foundation will be very much strong as compared to other structures. Here the physical properties are very much high compared to other soils, so that we need to go for the stabilization, physical properties as well as engineering properties, both we have to observe. After that, what we are having is in its broadcast senses, that means broadest senses. Broad means huge amount of sensing properties. Stabilization includes compaction. Here, compaction we have observed in the first chapter itself. That means different layers we are compacting by using rollers. That means what we have observed in this first chapter are sheep foot rollers, pneumatic wheel tail rollers, smooth wheel rollers, and vibratory rollers. All those rollers are normally used for the compaction purpose, and those rollers will decrease the content of voids and amount of water present in the soil. That is the major purpose of doing compaction in the site itself. Next one is the pre-consolidation. Pre-consolidation also related to this compaction, but in case of consolidation, especially we are doing removing the water content by using differential settlement process, like we are constructing sand columns and stone columns. Those are pre-consolidation techniques. Next one is the drainage. Normally drainage means, what we have to call as a drainage means, if there is no flow of water, automatically the water have to stay on a particular position for a long period of time. In those particular time, the water will absorb the surrounding atmospheric nitrogen, and automatically it will forms a reaction with the nitrogen, and the green color algae will be developed in the water itself, so that we have to face a huge quantity of foul smell, so that we have to face different that means we have to face different problems. Whenever the water have no movement, automatically mosquitoes will grow and the soil properties will change, and surrounding people and structures will have to face few difficulties, so that a drainage is also very much important. And next one, many other such processes. Likely, first we have to observe compaction process. After that, we are observing pre-consolidation in the form of stone columns and sand columns. After that, drainage. Those three are the very much necessary for every structure which will have to construct in a long manner. Next one, however, the term stabilization generally restricted to the process which alter the soil material itself to improve the properties. However, that means whatever it may be, the term stabilization is generally restricted to the processes. That means restricts means it will not allow some of the process which alter the soil material itself for improvement of its property. Altering means normally alteration. We are listened to this term normally for our clothes and other utilities. We are doing some quantity of alteration for looking purpose. Here also for strength criteria, simply we are doing altering. That means removal of some quantity of material and replacing with another material for obtaining good quantity of strength and engineering properties to the soil. Those phenomena we call as a altering, to get a good quantity of strength to the soil molecules. After that, a cementing material or a chemical is added to a natural soil. Here, cementing material, normally cement is used as a binding material in the concrete. Here also we are increasing the properties of the soil particles. That means especially we are using cement means automatically we are strengthening. That means compressive strength is increasing to the soil by simply adding a quantity of cement to the soil. After that, what we are having is a chemical. Normally different quantities of chemicals and mls of chemicals we are using for the purpose of strengthening properties. Normally in our houses, there may be a small cracks we have to observe. After that, observing small cracks, definitely we are using a doctor fix it or any other epoxy or bonds, so that those bonds directly restrict the enlargement of the cracks. Likely here also we are using cementing material and chemicals to strengthen the soil. That means if we are using this cement and other chemicals, automatically those will not allow any other material or destruction due to additional loads. So that we have to go for this cementing material and chemical properties of a particular material to strengthen our soil properties for stabilization criteria. Next one is the soil stabilization methods and their use. What are the different soil stabilization methods in our day-to-day construction work and their usages in different fields? Why? Because if you are constructing a structure, it is limited to a particular quantity of area, whether it may be 1,000 square feet or 5,000 square feet for an apartment or a small structure. And we are going to construct a huge quantity of dam. It will be having huge amounts of a thousand, 100 to 1,000 acres of land, normally used for the construction of a dam. After that we are going to construct a road. The length will be varies. If it is a small scale road, that means a residential in residential areas we are constructing a road, means it is limited to a 10 to 15 kilometers or 20 kilometers. But in case of large projects like national highways, it is going to a thousands of kilometers. Likely we have to observe what is the construction criteria, whether it is a small scale construction or large scale construction. If it is a small scale construction, definitely we have to invest a small quantity of amount, that means economy for a structure. If it is a large scale structure, that means automatically we have to spend more quantity of money. In those particular cases we have to reduce the spending, that means reduce the economy simply by using different waste materials which are coming from our day to day industries. That means day to day industries we are observing fly ash, GGBS, stone dust. Likely we are having different chemical wastes and solid wastes we are obtaining. We have to simply use those materials and giving strength to the soil. Those also includes a money free, that means economy free to our projects. So that we have to observe what are the different stabilization methods and their usage levels. Here usage means we have to use different quantities of waste materials for the purpose of stabilization of the soil and improving the engineering properties of our soils. First of all, the soil stabilization method is defined as the method of altering or modifying soil. Altering or modifying means simply we have to remove a small quantity of matter and replace with another chemical or cementitious material or another strengthening parameter. That means it is a soil or cement or any other chemical, whatever it may be, we have to add and we need to obtain a good quantity of strength to the soil, especially in the form of properties, engineering properties, to improve the characteristics of performance of a soil. Performance means automatically whenever the soil performance we have to observe means we are giving a load to the soil. Automatically due to the application load, soil will have to deform. If there is no deformation means automatically the soil is very good in strength properties or engineering properties, so that whenever the stabilization is done, automatically soil will allows a good quantity of load bearing capacity. Next one is the soil stabilization method. In other words, can be defined as the various methods used for modifying the engineering properties of a soil to improve the engineering performance. That means soil stabilization methods normally gives a good quantity of strength to the structure, that means substructure, and it will allows a proper bonding to our structural elements like footings. Normally whatever the different structural elements we are having like beams, columns and slabs and foundation, in those above the ground level we are having columns, beams, slabs. Below the ground level we are having only footings, so that there may be good quantity of bond between the footing to the surface. It will be transfers huge amount of stresses to the structure, so that we need a good quantity of bond between the footing and substructure. So that in the stabilization method we have to consider those things also. Soil to improve engineering performance, that means if there is a proper stress distribution, automatically structure is in safe condition. If there is no proper stress distribution, simply the stress have to mitigate the total structure itself. That means the soil have to distribute some quantity of loads to the soil. If the soil is not taking those loads, automatically those loads will be internally increasing. Due to the internal increment of those loads, automatically we have to observe different buckling or crippling or failure mechanisms in our structural parts. Next one, soil stabilization methods includes the mixing of special soil. Normally soil means a different combinations of carbon, hydrogen, silica, magnesium and other contents. So that here special soil means automatically a special material is added up to a some content, so that those soils we will call it as a special soils. Why? Because those are having some expanded engineering properties. That means incrementing engineering properties, so that those are called as a special soils, like cementing material or other chemical materials that are added to our natural soil to improve one or more of its properties. Next one, it can also be done by mechanically mixing stabilization agents. That means mechanically mixing means we have to use some quantity of these rollers. That means rollers means normally whenever we are having a construction, automatically in those particular places we have to observe these mechanical mixing equipments like cement mixing equipments. All those are we have to observe. Likely here also, to strengthen the soil parameters, we have to use some quantity of soil plus another cementitious material or any chemical, so that we need to use some quantities of mixing agents in the form of mechanical equipments. So that if we do this mixing process with the humans, it will takes a lot of time, and automatically the stabilization is takes for years and years and years. In case of humans, simply we are using any machines, automatically it will decrease the time and increase the property and strengthening mechanism. So that we have to use some quantity of stabilization agents for a natural soil to achieve a homogeneous mixture. Here homogeneous means automatically the total particles are mixing very well with another cementitious or this chemical content, then only we will obtain a good quantity of strength. By adding stabilization material like soil deposits, whatever the soil is present on the top layers of the earth, those soil we have to take, and another 5 to 10% of a cementitious material, chemical material we have to take. We need to mix those two materials in a well manner, then only we will obtain the strength. Next one is soil stabilization methods are used to improve the properties of road based soil. That means road based soil we have to observe. This is the key term in this particular sentence. Here road based soil means if you want to construct a long span road, that means for a national highway we are constructing a road for transportation purpose, likely we need to go for soil stabilization. Whenever we have to go for soil stabilization means automatically if the existing ground is very weak in engineering properties, automatically we have to go for these soil stabilization methods, and we need to improve the particular strength parameters of the soil by artificial mechanisms. So that we have to go for these road based soils. That means whatever the road is based on the soil, those soil we have to remove up to a such content, and we have to replace it with another material. Next one, these soil stabilization agents can improve the maintain soil moisture content, increase the soil particle cohesion, and acts as a cementing and waterproofing agents. Here what we have to observe is the soil stabilization agents. What are the soil stabilization agents? Are simply chemicals and cementitious materials. Those are soil stabilization agents. What are the work is? They can improve and maintain soil moisture content. That means improve means soil moisture content they have to improve. If it is a normal structure, the normal structure will have to bear huge amount of load without water content, so that below the foundation level we need to use this soil cement mixture, so that the water will not enter upward the structure, so that the structure is safe against this water control. And next one is the increase the soil particle cohesion. That means soil particle cohesion. Cohesion means one molecule and one molecule are bonding together in a strengthy way. Those kinds of things we have called as a cohesion. So that if the cohesion property is very high, automatically there may be huge amount of strength with our foundation to a soil, and it acts as a cementing and waterproofing agents. Cementing means strengthening agents, waterproofing means a tight structure without entering water. Next one, civil engineering faces difficult problems while road based soil is found to be a clay soil. In most of our civil engineering structure, if we are constructing a project in the clay strata, automatically the clay strata is very fine particles and they will absorb huge amount of water, less quantity of water, so that we have to face a lot of problems while we are going for construction, so that we need to use some road based soil in the form of these clay soils. After that, soils that have more clay content generally have a tendency to swell more when their moisture content is allowed to increase. Here the major keyword what we are using is swelling. Normally swelling means improvement of surface due to entrainment of water content. Normally those we call it as a swelling parameter. Here swelling is more when the moisture content is allowed to increase. Automatically the soil is allowed to absorb water. Automatically due to the absorbance of water, the volumetric change will be very more due to this content of water is increasing day to day due to these absorbance parameters. So that we have to decrease the absorbance simply by using these chemical materials and cementitious materials. Those will interlock the structural voids. That means particle to particle there may be some small voids are there. Those voids will be filled by these chemicals or cementitious materials. Automatically those will block the entrainment of water. Next, there are much research has been done to improve the soil properties by stabilization measures. They are having various additives in most cases, like clay soil in pavement work and cement and lime stabilization. In the previous different points we are discussing, all those points are simply giving as a conclusion sentence here. That means a huge amount of research has been done to improve the soil properties. That means a day by day, we are facing different difficulties in our construction criteria. That means construction sites, so that the scientists have to implement. That means they have to found different agents to restrict those problems, so that a researchers or a research scholars have to do different experiments in their research work to improve the soil bearing capacity and other leakage parameters, so that they are discovering new things in the construction, likely by using these cementitious materials and grouting materials and injecting resins, epoxies, polymeric agents. All those things nowadays we are using in our construction parts. That means whenever in the olden days, if there is a small crack obtained to a structure, automatically the total structure has to demolish and we have to go for a new building. But in case of nowadays we are simply using repair and rehabilitation techniques. In those repair techniques, simply if there is a crack formation, then the first major thing what thing we have to do is simply we have to find what is the thing responsible for the crack formation, so that it is a active thing or passive thing. In those things, those two things are we are having active thing and passive thing. Active thing means automatically it is simply increment. Active things means if it is a passive means automatically there is no increment, simply the formation is stopped at a particular position. So that we have to observe whether it is a active thing or passive thing. If it is an active thing, automatically the reason for activeness we have to found, and those activeness we have to restrict. After that we need to seal those cracks. Likely here also we have to observe if there is any settlement occurring onto the soil. First of all we have to found what is the reason for the settlement. If it is a water absorption or any other settlements or shear strength or any other failure or surrounding soil moisture, surrounding soil moisture content, all those things we have to observe, and we need to restrict by different stabilizations and things. First one, we are having two major kinds of stabilizations are in situ stabilization and ex situ stabilization. That means in situ stabilization means in our site itself we have to implement these stabilizations. Second one is ex situ stabilization. From the surrounding soil conditions we are facing a lot of problems, so that we need to restrict those surrounding soil problems by simply constructing a peripheral wall or any other peripheral grouting techniques or stabilization techniques. Those will not entrain the ex situ conditions into our soil. Here note points are two there. We have to observe those 2 points. First of all, stabilization method is not a magic tool. That means it is not a magic, it is a engineering tool, and some scientific mechanism is there. Due to those scientific mechanism, all the work have been implementing simply by bonding and breaking and collapsing. Magic tools which will soil properties can be improved for a better conditions. That means in the previous state the soil is having very weak properties. After using these parameters, automatically that means stabilization or grouting parameters, the strength of the soil may be increases. Why? Because it is not a magic tool, it is a engineered principle, so that we are getting a good quantity of strength to the soil. Next one is the amount of additives and mixed proportions depends upon the soil properties have to be modified. Here modification means simply we are doing some adjustment. Modification means automatically adjustment we are doing in the form of additive adding. Simply we have to add some quantity of additives. That means external soil agents, those we are called as a additives. To mix the soil depends upon the parameters. In the previous case the soil having some quantity of shear strength, some quantity of liquid limit, some quantity of plasticity index, so that we need to change those properties simply by adding exterior materials from another lands or another industrial wastes, so that those will restrict the properties and increase the engineering properties. The first four major important properties every engineer wants to improve. It means whenever we are going to construct a project, we have to observe the four major things. That means five major things we have to observe. What those are? Volume stability. Volume stability means simply how to draw a volume stability. Normally it is a particular volume. If there is any increment of water, that means simply we are adding some quantity of water, automatically the volume may be changing to another content, so that we need to restrict the content of volume. Second thing is the strength parameters. Strength parameters are majorly depends upon the particle bonding and their chemical content of the particle, and parameters influencing the soil and site itself. Next one is the compressibility. This compressibility having an effect due to this content of voids. If the voids are very much high, automatically compressibility also very high. Voids are low, automatically compressibility also very low. Next one is the permeability. This permeability also majorly depends upon voids. If there is void, means automatically those voids will have to absorb the water and increase the soil volume conditions. Next one, durability. Durability, that means if there is any content of matter which we have to add to the soil, automatically due to those content of waste matter, our soil will have to deform its shape, size, texture, color. Those things we have to represent with these durability properties. Normally we have to observe our buildings. At the early stage of our building, whenever we are going for painting, it will be simply sparking in the early years. After 2 to 3 years, simply the sparkness will be removed by exterior parameters like wind and some quantity of water in rainy season, and automatically heat due to this sun's atmosphere and surrounding waste gases. All those waste gases will be absorbed by the calcium content in the paint and cement. All those will absorb those waste gases, and simply the building will be converting into another color. Those things we are call it as a durability properties. If we keep a particular steel rod in the atmosphere, automatically the steel rod initially in the color of a cementitious color. Why? Because will be, they will be coat in the industry. That means cement coat will be given to the steel rods. Those cement coat will be acts as a preventive to absorb the water. Automatically, if the rods are keeping for a month of a period, that means a 30 days period, automatically the external environment will having huge amount of humidity in night periods. That means in the evening periods we are having huge amount of humidity. Due to those humidity absorbance by the steel, automatically it will deforms its color and shape. Simply the steel will react, ferrous react with hydrogen and simply converting into ferrous hydroxide and ferrous hydrates, so that simply it will be converting into red color matter. Those are the durability properties. Likely here also some of the soils having different contents of minerals. Those minerals will absorb the air and other impurities present in the soil or external environmental like wind or any other water from the surrounding fields, so that they will have to go for this deformation due to these durability properties. Next one, we have to observe some of the stabilization properties we are having. What they are? In road construction work, soil and gravel are used as a main ingredients in pavement layers. That means for a road we are having different layers. Top layer we are having a pavement. After that we are having sub pavements and base layers. So that for a top layer only we are using this cementitious, like whether we have to go for a cement road, normally cement material we are using. Whether we have to go for a tar road, normally bitumen is used for constructing a flexible pavement like tar roads. If we go for construction a rigid pavement, automatically we have to use cementitious material. Likely soil and gravel are used as a major ingredients in the pavement layers. That means below the surface of the rigid pavement or flexible pavements, we have to go for a layer by layer of these contents of gravel and soil mixture. On the bottom layer we have to use a large size gravels. Simply those are 40 mm to 60 mm we are using as a large size gravel molecules in the bottom layer. After that simply we are decreasing the size. After 60 we are go for 40, 20, 10, 5. After that simply we are giving a pavement, rigid pavement or flexible pavement. That is the total construction mechanism of a road. After that, for that requirement properly, tensile stresses and strains spectrum, the soil used for construction pavement should be a special specification. Why? Because the road have to bear too much loads. That means whenever the vehicles are simply moving, so that the tire will give too much of stresses to the road. Due to those stresses, there may be a compressive stresses or tensile stresses they have to observe. If it is a normal position, automatically the tire will give a compressive loads. If the road is like a uh, that means a circular path, automatically the road have to bear these tensile forces due to the moving of vehicles in a circular path. Like the different stress strain spectrums have to be up, have to be bared by a road due to the movement of vehicles in the stabilizer. That means in the different contents of the roads. After that, by using the soil stabilization, unbound soil materials can be stabilized with cementitious materials. Here, unbound soil materials. Unbound means there is no bonding between the different particles in the soil, so that we have to give some external bonding by these stabilization agents like cementitious materials, fly ash, bitumen, or combination of one with another. That means cement with fly ash and cement with lime, and bitumen with another quantities of fly ash to improve the bonding parameters of a soil particles, so that the stabilizer soil molecules having higher strength compared to a previous unbonded molecules. Lower permeability, that means the soils will not allow any content of water into the below layers of the soils. And lower compressibility, that means the total forces will have to transfer to surrounding embankments. Automatically the sublayers having too much, the less quantity of absorption of these stresses and tensile forces compared to a native soil. Soil stabilization can be done in two ways. Those are in situ and ex situ. After that, we are having different soil stabilization methods. What those are? Normally here we have to observe totally 11 soil stabilization methods are there. In those 11 methods, we have to go for a different contents depending upon the soil criteria and our construction site parameters and our project value. First of all, we are having mechanical soil stabilization method. Here the term itself we are having mechanical. That means we have to use a large mechanical devices for stabilization criteria of a soil, so that the method is called as a mechanical soil stabilization methods. Likely rollers or mechanical equipments. Those rollers will give a stabilization by reducing content of voids and water. Next one is the lime soil stabilization method. Lime means normally a calcium agent. That means what is the content of a lime is calcium oxide or calcium carbonate. Those calcium oxide or calcium carbonate simply we are mixing with the existing soil, so that we have to get a uniform content of this lime soil stabilization, lime soil matter. Those matter we have to mix with the existing ground in a well manner, then only we will get a proper strength properties. Next one is cement soil stabilizations. In the previous case we are adding a lime to the soil, but in case of cement soil stabilization we have to add some content of cement with soil matter, and we have to go for stabilization and giving strength to the soil by well mixing those elements, and we have to spread in a equal manner. Next one is the chemical soil stabilization. Here different quantities of chemicals we have to use. That means those are unbonded, that in some of the soils are having pure unbonding tendency. In those cases we have to use these chemicals, so that those chemicals directly give bonding of particles. Those due to those bonding of particles, they will not allow entrainment of water. Next one, fly ash soil stabilization. In this fly ash soil stabilization we have to mix fly ash with the soil. After that, rice husk ash soil stabilization. That means In case of fly ash or cement or lime, we have to use rice husk. Why? Because if we have to use this lime, automatically after few days the total lime resources in our soil will be at a poor stage, so that we have to use another alternative materials. Why? Because in some of the areas we are having huge amount of rice generation. That means rice mills are there, automatically we are getting rice husk as a waste material. Simply we have to use those rice husk waste to stabilize our soil. Automatically it will decrease the money and increase our soil properties. Likely fly ash also in some of the thermal power plants will produce lakhs of tons of these fly ash, so that we have to utilize those fly ash whenever there is a needy regions. Next one, bitumen stabilization. This bitumen stabilization normally is allowed to a flexible pavements. Why? Because flexible pavement having a bitumen utilization on the top layer, so that it will give more bonding tendency to the layers. Next one, thermal stabilization. Normally this thermal stabilization is mostly used to the soil profile which is having huge much amount of content of this water. Then only we have to go for this thermal stabilization. That means due to these thermal properties, automatically the total content of water will be evaporated and the soil will be stabilized. In case of any harmful matter is there in the soil, automatically due to this thermal content will be supplied to the soil, those bonding will be reduced and automatically those are weakened. Next one, electrical stabilization. This electrical stabilization also we have observed in the form of electrical osmosis in second chapter, so that it is also a one stabilization method. Next one, stabilization by geotextiles and fabrics. That means geotextiles means automatically we have to use some quantities of polyethylene and polycarbonate. That means the plastics. Those plastics directly we have to use in the form of land stabilization techniques. Why? Because plastics are having huge amount of strength. They will not degrade into the soil for lakhs of years, so that we have to go for this polymeric stabilization in the form of geotextiles and fabrics. That means not we have to use cotton. Why? Because cotton have degrading capacity. Whenever we are using this cotton and other matters, simply they will be degraded easily whenever there is a content of water. But in case of plastics, those plastics will not be solved in the water. Automatically we have to go for a long span of years for getting good quantity of parameters. Next one is the recycle and waste products. Different recycled products, like nowadays we are observing different roads are constructing with this plastic waste. That means in our daily life we are getting huge amount of waste polythene bottles, so that we have to use those polythene bottles up to a 20 to 30% as a replacement of this tar or bitumen, so that we have to replace those contents and we need to construct a huge amount of length of flexible roads. These are the different stabilization methods. In the next class we have to discuss one by one in a elaborated way. That means what are the different sub criteria in those techniques.